Hi guys, welcome to chapter 6. We're going to cover sections A and B today. We're finally getting into earthquakes, okay? So you can follow along in the book with me. An earthquake actually has a scientific definition. It's any shaking of the ground, okay? And it's usually because of the fault, and we'll talk about a fault in a minute, slipping, okay? So remember, we've got these plate boundaries. The Earth's crust is cracked into all these pieces. Where they meet is where a lot of this movement occurs. Okay, we use a seismometer to measure the earthquakes. Okay, these earthquakes send energy out in all directions as seismic waves. We'll talk about those a little bit more, and those are measured with a seismometer. And again, the fault is that crack in the rock. Okay, so it doesn't have to necessarily be just the boundary between the actual plate tectonics or the plates themselves, but sometimes the crust cracks again, and so smaller fractures can occur, and those are known as faults. Okay. All right, so we've got lots of forces happening in the earth, different directions, different movements. Stress is that force. Okay. I know we talk about being stressed, but in terms of earthquakes and earth science, stress is a force exerted inside of the material. Okay. And we have three main forces we're going to talk about. First one is compression. Compression is when things get pushed together. So you can think of like an aluminum can getting crushed. That would be compression. Okay. Tension is the opposite. If something is getting pulled apart, okay, like a spring or something, and pulled away from itself, that is tension. And then finally, shear is a little different. So if you have two pieces of material, if they slide past each other like this, that would be shear. Okay. So compression is towards, tension is away, and shear is just sliding past each other like that. Okay. There's another force that has somewhat to do with this. We'll talk about it more in 8th grade with water. But this buoyant force, when you float in a pool, that's because of the buoyant force. Okay. So buoyant force is just an upward force. It acts against gravity. It kind of counteracts gravity. And that's why some things float above other things. Okay. Now, with earth science, that's involving the different types of rock. Okay. Sometimes we have liquid rock, we have molten rock, and sometimes we have cooler, more solid rock. Okay. The cooler, denser rock tends to sink, whereas the hotter, less dense rock rises. Okay. So we talked about seafloor spreading. The magma comes up. That's because it's less dense. But then in subduction, it cools off and it sinks down. That's because it's more dense. Okay. All right. Now let's talk about these plate boundaries. Remember, the crust is broken up into these little pieces. I don't know if you can see that with the glare or not. And those connecting points, the places where those plates meet, are known as boundaries. Okay. And we get three different types of boundaries. I showed you a map before of those plates, and you could see little arrows on there. Those arrows kind of represent the different types of boundaries we have. Okay. So we have divergent boundaries. If a road diverges, that means it splits. And so a divergent boundary is when the plates are moving apart. Okay. So again, I'll use my blocks. If they're moving apart away from each other, that's divergent. Okay. The stress with that is tension. Okay. The same direction as tension. A convergent boundary. So if a road converges, it comes together. Convergent boundaries push together. That happens with subduction. That is compression. Okay. And then finally, we have a transform boundary. That's just when the plates slide past each other. Okay. And the force for that is shear. Those are our three main plate boundaries. Divergent boundaries, that happens at seafloor spreading, spreads away. Convergent, subduction. It's pushing into the other plate. And since it's more dense, it sinks down underneath. Okay. All right. So strain. Strain is any change of shape of a material. Okay. When a car gets hit, there's a dent. That's because of the strain of the metal. So there's a lot of strain in rock during an earthquake and during the movement at these faults. Okay. Ductility is the ability of a material to stretch. Okay. Certain metals are very ductile. They're soft enough that you could pull them and stretch. If you've ever played with silly putty before, you can kind of picture that. Or gum, when you pull gum out of your mouth, it stretches, it doesn't break, okay? Some materials, though, are very brittle. They don't stretch at all. If you pull them, if there's a lot of tension on them, they snap, they don't stretch at all. And so you have these two pictures here. This would be an example of a more ductile metal, and you can see that it narrowed up here. So it actually kind of started pulling apart and it gets skinnier. This is how metal is made into wires. It gets skinnier and skinnier and skinnier. This was a more brittle metal. It didn't stretch at all. It just pulled and then snapped, okay? Well, the same thing can happen underground with rock. Elasticity is another thing we use to measure materials. It's the stretchiness of a material. Rubber bands are very elastic. Springs are very elastic. Rock can be elastic, but it tends to not be super stretchy. So if I have a very strong but brittle rock, they're going to release. They're gonna withstand the stress, withstand, and then just snap and break, and that releases a lot of energy that we feel as an earthquake. Okay. But if the rock is elastic, if it stretches, same thing. It's going to be able to take a lot of energy. And if you think of a rubber band, you can pull it, and then finally it breaks. And when it breaks, it snaps really hard. There's a lot of energy being released from that. Same thing with the rock underground. Okay. All right. So faults, talked about it a little bit more or a little earlier. Faults and joints. Okay. A joint is just a crack in a rock. It really doesn't matter the size of it. A fault is when there's movement along that joint, okay? So there's some kind of stress causing a little bit of movement there. A couple more pieces of vocab before we talk about some specific faults, okay? The strike of a joint or the strike of a fault is the horizontal direction, okay? So horizontal is this way. So the strike would be like along there. Okay. If this was my fault, the strike would be the direction horizontally. The dip describes the angle of the face of the fault. Okay. So here are my blocks again. Okay. If this is the surface, this would be the strike of the fault. This would be the dip of the fault, okay? Because it has to do with the angle of the face of the crack. The crack isn't just at the surface, it extends underground in the rock, okay? Sometimes you get a straight dip, there's no angle, and then it could tip to either direction, okay? That direction is going to determine what kind of fault we have. It's kind of hard to explain this. We've got two other vocab words here. We've got the hanging wall and the foot wall, okay? The hanging wall is the part of the dip that's above the crack, okay? And so this would be the hanging wall. Below the crack would be the foot wall, okay? And I can turn it this way, and then this becomes the hanging wall, and this is the foot wall, okay? And those are going to be important to understand when we talk about our three main types of faults. Our first one is the normal fault. And so that's this guy right here. With the normal fault, we're experiencing tension. Okay, so remember, tension is when things are getting pulled apart. Okay, with tension, as I pull these apart, look what happens to the hanging wall. Okay, because they're not being held apart anymore, the hanging wall slips down, and so the dip forms this low part up here. Okay, so the hanging wall moves down because both of these pieces are moving away from each other. Okay, that's a normal fault. A reverse fault is just the reverse of that. So we've got compression. So these are being pushed together. This is the hanging wall. These are being pushed together, and so the hanging wall goes up. Okay, here is our reverse fault right here. So these are being pushed together, and so the hanging wall goes up. And then our third is called a strike slip fault. Only horizontal movement. There's no dip, okay? And so there's no angle, okay? We just move side to side, okay? There's none of this up and down movement, and that's a result of shear forces, Okay. All right. Tons of vocab. Study, study, study. All right. See you later.